think we're streaming. Let's give Twitch and the relevant services time to kind of catch up. Well, that's probably better. Okay. Let's see where we're at. Looks good, looks good. I'll get stuff in place for now. Okay, so we are in week 7, I believe. Kind of came a long way. So why don't we take a look at what we had planned. Go ahead and okay. So Mudsy. This week we're going to be doing a review and a deep dive into our game. I got a great recommendation from someone that said 6 patterns is quite a bit, and before we go any further, it'd be nice to let people catch up, to dive into what we've done so far, and explore where you might actually run into some problems. It's actually really easy and something that can be done subconsciously to get right up to the point of resistance, right up to the point where the pattern is about to fail you and back off, right? We see this a lot with tutorials where they'll show you a very basic example of something, and that example will get parroted everywhere. And you only find out once the rubber hits the road that the framework, the software, whatever you're using, is actually very difficult to keep using past a certain point of complexity. So, in the first phase, we did the factory pattern, the strategy pattern, and the bridge pattern. In the second phase, we did the command pattern, the state pattern, and the flyweight pattern. So, pretty intentional. Try to get one of each type of pattern, whether it be creational, behavioral, structural, and also try to choose those patterns somewhat organically. Wanted them to come up within the game, but there's a little bit of intention behind which ones were chosen when. So the biggest takeaway for a design pattern is that there's always going to be an abstraction. And the thing you're abstracting is going to be whatever the name of the group is. So for the creational patterns, we're abstracting away the creation. If it's for the behavioral pattern, it's the behavior, and for the structural pattern, it's the structure. So you're always going to have an abstraction. And an abstraction can be either an interface, an abstract class, a base class. That's really it, really just those 3. And then once you have your abstraction, this thing that defines the functionality, whether to create how something behaves or how it's structured, once you have that, then you can refine the abstraction. So you bring it closer to your concrete class. So abstraction, refinement, and then you have your concrete implementation. So every design pattern you run into is going to have those 3 basic tenets. And once you understand that, and it's buried quite deep in a lot of online literature, once you have that kind of construct, it's easy to look at things like in phase 3 we had started off kind of saying we're going to do the adapter pattern. Well, it's actually quite easy to look at the adapter pattern and then say, let's just look it up real fast. Alright, so the definition of the adapter pattern, which is one we haven't done yet, the definition is to convert the interface of a class into another interface clients expect. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces. So you have to kind of infer here a little bit, but we're talking about presumably 2 domains, or at the very least 2 classes. And we're assuming that when we say interface, we're talking about our abstraction. So we've got 2 different abstractions. And how do we get those 2 abstractions to communicate? So we have to create our own abstraction for that structure, and then create a refinement that's going to take our common elements and allow them to speak, and then we're going to create a concrete implementation. So it's not necessary that we do every design pattern in the book, and it's not necessary that we have a kata that we run through for every one, but we should be able to do enough katas from each one of these groups to really understand, just at a glance, what the intention of a design pattern is, at least at this basic level. So, in our game, which is Canadian 1010, says, hey, hello there, Canadian 1010. So, in our game, we have the beginnings of a pretty nice presentation tier, or a rendering tier, or user interface. These are always going to be kind of the different terms for the same idea. So we create our hive mind. So let's jump into that guy real fast. So inside of our hive mind, we create a new grid, which is essentially a sheet of a certain size, and then rooms. We have a new response stack, which is going to keep track of all of our game responses. And then we're going to seed the world, right? So we're doing this because we don't have a database, we don't really have any of the persistence tiers set up, so we're just going to give ourselves some dummy data to work with. And then underneath of our constructor, we can see our properties that have been defined for the response stack in the world. And then we got our inside of here, we got a pattern for the command pattern. So our hive mind can execute requests. So when we're talking about the command pattern, what we want to do is create an abstraction for the processing of requests, and that abstraction is going to be present as, in our case, I believe it's an interface. It's going to allow us to communicate with classes that have nothing to do with the hive mind. Canadian says, add a database like MySQL or SQL Server to that project. There's so many options, Canadian. We don't even know what we want yet. Maybe, though. Maybe MongoDB, right? We could do anything. Maybe like just one of the new document DBs from Azure. So tons of great examples for the persistence. So for the command, we can apply our abstraction, right? In this case, an interface. So in this interface, it's more like a contract. And then whatever we slap this contract on, we can deliver commands to. That's really powerful. And if we go into our iGame object, we'll see that we decided to throw this abstraction for the command pattern onto the very base common element of our world. So everything in our world is a game object, which means we can rely on everything having a name, a description, an object key, dexterity, hit points, a type, a state, and then respond to these methods. And inside of the game command, we say, in addition to those things, everything should have an execute method and a check state. So it's very basic. Our command pattern is this abstraction. We then look at our iGame object as a refined abstraction, right? So we're just taking these two abstractions and knitted them together. And then inside of our base game object, we've got this implementation. And we decided in our implementation to make these two things abstract, meaning that we've deferred the implementation to something that's going to inherit from this base class. So far, still pretty basic OOP, pretty basic C#, pretty basic classical inheritance, and we're just kind of throwing this concept design patterns on top of it. Alright, so that's about as far as I'm going to go into kind of the academics and lexicon of all this stuff. What I want to do is start playing the game, start adding in new features and building on top of what we already have, and then as we run into design patterns, maybe take a second to explore, ask questions about why we chose those. Cool. Alright, so when I render my world, I get a test chamber, a description, targets that are available, and the players that are available. And this all came from my seed world. So I can type in gobbledygook here, and I get back, sorry, no command matched your request. I'm going to type in attack Beth, and no command. It's actually fight Beth. And then I get Gary attacks for 8 damage. I can then look at Beth, and I get some descriptions that are kind of difficult to read. Looking at Beth, appears strongly built. Army vets are known for being tough. A wide array of tools and weapons can be seen attached to various belts and loops. Health 132. So let's do fight Beth. Look Beth. Okay. So I'm in a console, so I can just hit the up key to get my last commands. So, one of the interesting parts of the game so far is I'm attacking Beth, and that's using up my stamina, which are my turns. So, if I look at Beth again, I'm not actually strong enough to kill Beth before my turns run out. I like this. It's kind of a happy accident. We can definitely, and we probably will for testing, jack up Gary's attack pretty high so we can see what happens when a player dies. But for right now, let's just look at, so I got 0 stamina. She has 60. Okay, so for the first little bug, I don't want my stamina to decrease past 0. Let's go to my hive mind. Into my game execute. And so I could, if we go back over the program, I've got a command parser. And the reason why I don't want to do things here is because this is inside of my rendering tier or my UI tier. And so these rules that I'm getting ready to write, I want them to apply to anything that can happen or anything that might be calling the hive mind. So, and then here I say if the sender of the request is out of play, sorry, out of play. So let's go ahead and also say, or if the target dot game object state is equal to game object states out of play. So if either the person requesting or the target are out of play, we want to say that sorry, blank is out of play. But there's no real good way. We might have to repeat ourselves here. Let's go ahead and copy this out and then take a look at it. Alright. And so as always, we're not really quite working on this yet, so I'll come back to it, but anytime that you have